Hi, Mike Matchett with Small World Big Data. Today we're talking about a fascinating topic, and that is diving deep into chip design. We're talking about ASICs and SoCs, systems on chips, and what they mean to us here in the IT space. We're all buying and are being sold a lot of accelerator cards, a lot of cards that we plug into our computers that should make them do actions and activities faster, whether it's network offload or storage or I/O offload or virtual private security kinds of things that are going on where we plug in a card. Those are all powered by ASICs. And we're going to talk today with Douglas Fairbairn from MegaChips, and we're going to figure out just exactly what's going on when someone comes and tries to say, I've got an offload card, what's inside of it? Welcome, Douglas.
Hi, glad to be here.
All right, so just start a little bit. You're kind of a well-known luminary in the field of chip design. Just tell us a little bit about your background and MegaChips' background and what MegaChips does in the broader sense.
Okay, great. Yeah, my background is in semiconductors and software. I was a founder of VLSI Technology way back in the 1980s. I was then became CEO of a design automation company, Redwood Design, and later acquired by Cadence and spent several years there. So I've spent decades in the semiconductor business and specifically in the ASIC business. In the process of doing that, got to know a unique fellow in Japan. His name is Masahiro Shindo, and he was previously at another company. But the unique thing is that he was an entrepreneur, a founder of a company in Japan, which is called MegaChips. And in 1990, he did a startup, bootstrapped himself into what is now a billion-dollar company in Japan that's doing extremely well, very widely known, very highly trusted in the Japanese market, but quite frankly, largely unknown in the US or the rest of the world.
So $1 billion market, 30 years doing custom ASICs for different kinds of companies that need them for telecom and industrial uses. What else do people use custom ASICs for?
Yeah, so they go into a wide variety of functions, certainly office equipment, wearables, things that your watch or your smartwatch or headphones, earbuds, your cameras all have some sort of ASIC in it, especially the higher end things that do autofocus and so forth. So in almost every kind of compact consumer device, certainly your PCs or whatever are all going to have custom devices in them.
And the big thing today is, of course, pushing that technology out to what we think of as the edge. So we want not just consumer products, but in more of the IT space, all our devices that are going out to the edge need to become enabled. They need to become smarter. We might want to run intelligent software on them that does learning and inference and other activities out at that edge. And this is something now that you guys see as a burgeoning market.
That's right. So this whole world of AI and machine learning really just exploded about 6-7 years ago, 2015, 16, when there were some major breakthroughs in terms of how to accelerate and how to really make artificial intelligence work. It's been a promise for 50 years, and all of a sudden, people put the right software and hardware together to make it work. The first place that found instantiation was in the data centers, in the Google data centers, or Amazon or Facebook or Apple or whatever, and they use very powerful chips to do that. First, they were trying to do it on Intel processors and found that didn't work very well. And then they discovered that the graphics processors from NVIDIA and others, could vastly accelerate those. So they started to offload to the graphics processors. And then they discovered, oh, if we build custom chips that have some similarities, have some DNA from this graphics world, boy, we can really make that work. And so as the whole world of AI exploded and the necessity of doing online voice recognition and image processing at a scale that had never been attempted before, the need for huge amount of processing in the data center exploded. Now people are, over the last few years, saying, look, we cannot handle this exponentially increasing load at the data center. Plus, we can't stand the latency of sending data to the center and coming back.
Yeah.
And we are giving up privacy. We want to do all of that processing. We want to process images. We want to do facial recognition. We want to do voice recognition. We want to monitor the health of somebody wearing a medical patch. But we want that data local. We want that data kept on the person or in that person's private control. And so that's what we call AI on the edge. So we are being forced to take this need to process complex AI algorithms and figure out how to do it still very rapidly, but in extremely low power, very small kind of footprint. And that's what MegaChips is in the business of helping people take that AI processing that we've gotten used to using at the data center and move it to our own personal control.
All right. So, I mean, and that's a great summary. So we've got a lot of concerns with trying to move our processing out to the edge, distributed processing. There's a lot of reasons to want to do it, but you mentioned a couple things that are really problematic, like power consumption, speed, performance. I imagine size is a problem if you're trying to get something into small form factors. Tell us a little bit about what happens when someone starts to say, "I want to do AI at the edge" in their design thinking. What kind of cycles do they go through?
So the first thing they're going to do is say, well, gee, can I just run some new software on my
Yeah.
existing CPU? Everybody's got a processor in their device. And the answer is, well, once in a while, maybe, but in almost all applications, that processor isn't going to be fast enough. So then they're going to want to say, well, can I offload it to something? And to do much higher performance processing, you need very customized architecture. You cannot use the standard ARM processor or Intel processor to get the kind of performance and low power that you need. So there's been dozens of startups that have found a home trying to or raise money to try to come up with a new architecture that is going to meet this power performance constraint. Now there are too many choices. It's like the explosion of microprocessors in the beginning. There's a huge number of vendors out there, and now the challenge is which one is the right one for my particular application.
All right. So you, as microchips, then step up to the plate when someone has an idea or design and help them instantiate that as an actual chip. What kind of services do you provide someone who has an ASIC in mind?
Yeah. So the first thing we do is make sure that what they're trying to do can be practically implemented and at a reasonable cost and that sort of thing. So we have visibility from high-level design all the way through the manufacturing chain, so we can quickly determine that this is a viable product that you're trying to build or not, or you have reasonable expectations in terms of price, performance, power, that sort of thing. Once we say, yep, we think that's doable, then it's a matter of choosing the right solution. And in this case, it's choosing the right building blocks. What are the building blocks we're going to put together on an individual chip to get the best price, performance, and power envelope so that you will be successful and we will be successful. We have partnered with a couple of IP vendors, people who are selling these advanced architectures in the form of what's called intellectual property IP that can be put onto a SoC, a system on chip, along with an ARM processor, along with whatever amount of memory you need, along with whatever interface you need to the outside world, whether it's a MIPI interface to a camera or whatever. So we look at that whole thing and we say, okay, we will assemble all those building blocks onto a single chip for you, and then we will handle all the back-end design, manufacturing, and we will ship you a final qualified, tested chip that you can then take to market.
All right, so soup to nuts chips, right? I can say as an IT vendor, I need an offload, I need an accelerator, I need something to do some AI, exciting AI things especially at an edge kind of location, and you are the people that they should go to do this. Tell us a little bit about some of the partnerships that you've just announced for this AI technologies. You've made some investments, I understand.
Yeah, so we made a couple of recent announcements. One is a company called BrainChip, and they have very unique architecture. I spoke about having unique architectures, and everybody has in the space has looked to the human brain and said, well, gee, that's the model of perfection in terms of power performance. What can we learn from that capability? And BrainChip in particular has adapted some of the key concepts of what happens in the brain and brought that down into a purely digital chip that has some unique capabilities in terms of very low power. It can sit there drawing virtually no power until some event happens, somebody shows up, some voice is recognized or whatever, and then they come to life, consume still small amounts of power. They can even do some recognition on the fly. If you buy a doorbell with a BrainChip product in it, and you can actually train it to recognize you and the other members of the family so that it doesn't record you coming to the door. It only wants to record when somebody strange comes to the door. And so things like that. So this is a perfect example of something that can drop into an existing product, accelerate it, do some unique capabilities without drawing any significant amount of power. The second one that we've teamed up with company is also a relatively small company called Quadric, and they have also a unique solution. They've taken a somewhat different approach, and they're able to, with their technology, able to handle this whole pipeline from image sensor to final decision recognition. So whereas BrainChip might accelerate just one portion of that pipeline, the neural network, the Quadric product accelerates the whole thing. So each has its own application space. Each one has its own best customer, and we can help our customer to decide which is those, or is it another one. We are not wedded to either of these, but rather offer them as examples of what can be done.
So more building blocks in your a bag of tricks there that you can bring to the table for someone.
Absolutely.
And put together. 30 years of building ASICs for vendors must have taught you a lot of. You must have a lot of experience and things on there. I don't even know how excited this makes me, because I want to send things off to get 3D printed, for example, the 3D printing service. I've got ideas for chips, Douglas. Can I just send you my idea? Get some chips made on there. Probably might have to find some investors first for that. But there's a lot of happening. I mean, we see people making their own versions of AI chips like tensor processing units from Google. There's a whole raft of these coming to market for different IT folks to consider when they need to host AI processing. There's definitely edge technologies. I mean, we talk a lot about refrigerators and coffee pots, but there's a lot of devices in the IT space or in businesses that rely on OT, for example, to get their jobs done these days, and they're going to become increasingly smart. So a lot of things here. What do you see the future of MegaChips? Where do you guys see yourselves 5-10 years from now?
Well, we're going to continue to build ASIC chips, as we have for the last 30 years.
Yeah.
But we also see that in some cases, an ASIC or a fully custom device for a customer is not required or the best solution. So we may very well, once we identified and have more experience in the application space, come out with some standard products that maybe incorporate the IP that I've described, along with some standard interfaces and maybe a flexible amount of memory or whatever, such that we can get customers into this marketplace at a much lower entry fee than a custom ASIC might entail. The other thing I want to emphasize, is that there's so much focus these days on the very latest technology, a 5 nanometer, a 3 nanometer, a 7 nanometer design, or whatever that means. What people need to understand is that only the very highest volume, very highest performance chips are being fabricated in that technology. So yes, Intel uses that level of design. NVIDIA, which puts very high power, very high performance, but also very high power chips into the data center for AI processing, use those kinds of things. The kinds of chips we're talking about, we can probably fulfill the needs of the user at a much more relaxed process node that is not nearly so expensive. So 16, a 22, 28 nanometer, even 40 nanometer are perfectly practical and more accessible process nodes for those who are not trying to push the envelope in terms of ultimate density.
Yeah, and we understand that even when you get down to 5 nanometers, the power goes up because the resistance in the wires goes up with the
Yeah,
decreasing size. Lots of stuff going on there when you try to shrink too small.
yeah,
Sort of optimization before it's needed because we can do an awful lot there. You also have an expertise, I just want to mention, in marrying digital and analog processing kinds of tasks within that system on a chip, which is also comes into play when we talk about AI and DSP and some other things that go on there. Uh, Tell me, just I guess we're kind of running out of time here, Douglas. If someone wants to learn more, do a little more research into chip design or into ASICs, if they're looking at the solutions that are being pitched to them that have ASICs in them, and just want to get more background into what's going on, do you have something you'd point them to?
yeah. They can certainly go to megachips.com. I would also encourage them to look at our partners that have more examples on their website, brainchip.com or quadric.io. And most importantly, take a look there. But these are not simple questions you get simple answers to. So, take a look, but give us a call. We'll sit down with you. We'll consult with you. No, this is free consultation to figure out, is this a viable thing you're trying to do, and what direction should you take, and what kinds of building blocks. These sorts of things we can sort out very quickly, whereas you may spend hours, days, weeks trying to figure out things just exploring websites. So take a look at the website, but don't spend too much time there. Give us a call. Let's have that conversation. We can cut through a lot of the noise in a very quick period of time.
All right. Thank you very much for being here today. You've heard
My
it, folks.
pleasure.
If you've got some ASIC concerns, if you're looking ever for a system on a chip, design, concept, or just a consult, give them a
Yep.
call. Thank you very much,
Happy to do
Douglas.
that.
All right. Take care.